prevalence is what? Really measure existing cases. So you go there and just measure, collect data about any cases that you see. But with incidence, you have to know that the population is originally free of the condition, and then you have to wait for some time for new cases to occur. So that's what incidence is. So in order for incidence, to measure or collect data on incidence, the population has to be susceptible for the condition, and also time has to pass. So these are the two key elements in measuring incidence. So this is new disease event, that is the first occurrence. The population has to be at risk. When you say at risk, it has to be at a body organ, health behavior, eating habit, or lack of immunity. So the population has to be at risk at the beginning. And then the time must pass. You just can't go there and say it's new case. You have to make sure that originally that individual is what? Free of the condition. So you have to wait for some time for that new case to occur. So time must pass. So these are the two, these are the differences between the two, the prevalence and incidence. Now, when we say incidence rate, we are talking about what? Number of new cases during that specified period divided by the average population at risk during that period. I'll come to what we mean by average, but for the moment, just look at it in such a way that number of new cases, you count them, how many cases occur, say, during a week or during a year, and then you divide that one by population at risk during that same period, a week, a month, or a year. So this is what we call incidence rate. We call it incidence rate because of that time element, a week, a month, or a year. So again, as opposed to prevalence, which you said the other day, it's like still a picture, still life picture. Incidence is what? We like emotion picture, because it describes what is happening in a population. As I indicated initially, there are three components. Cases have to be new, population has to be at risk, and then time has to pass. So we always report incidence as a proportion, but most of the time really as a rate, per year, per month, or per decade. So as a result, our conclusion or interpretation would be what? Risk of disease over a specified period of time. So that is what incidence is about, incidence rate is about. But there are two ways of expressing incidence rate. That is what we're talking about.
Could you go to the previous slide real quick?
This one?
Yeah. Okay, thank you.
So there are two ways of expressing incidence rate. The first one is cumulative incidence rate, and the second one is incidence density rate. So both are different applications where one, you can only use one and not the other. So we really go over both of them. Cumulative incidence is what I just talked about. Number of new cases occurring during a specified period over average population at risk during that same period. So your period has to be the same all the time. If it's a week, it has to be a week both ways. So again, the scenario remains the same. A population is known to be free of the outcome of the condition at the beginning. So that's always a key. Then the population has to be at risk. Again, another important point is that always if you say population at risk, you should be able to ascertain whether the outcome occurs or not. So first event or outcome for each subject are detected. If you cannot detect that, then you really cannot talk about incidence. So the outcome should be able to be detected during that specified period. If you cannot detect or ascertain the outcome, then you really have to remove it from what? Your population at risk. So you should be able to detect whether the case occurs or not occurs. So this is one of the examples. So it says a pig farm of 100 sows was investigated for the outbreak of swine vesicular disease for 5 weeks. So that is really what makes it cumulative, for 5 weeks. What you report now in 5 weeks period. So that's what makes it cumulative. You don't go day by day or week by week. You can count them week by week, but the reports come what? During this, for this specified period of 5 weeks. But as I said, you can collect the data by day, but the report always comes during that study period. So as I said, we have 100 sows. During week 1, 20 new cases occur. So cumulative incidence during this first week is 20. Now incidence rate is what? Incidence rate is, cumulative incidence rate is just dividing what? Number of new cases by what? Population at risk. So our population is how many in a year? 100. So this just becomes 20 divided by 100, you can say per week, because that occurred in 1 week. You can put that as 1 week or per week. So always that you have to understand that when you are calculating incidence. So you can just say 20 cases, 20 out of 100 cases per week. Now, again, you have to know we are talking about what? Cumulative. So during the second week, how many cases occur? 5 additional cases occur. So what is the cumulative incidence over this 2 weeks period now?
35.
35, yes, it's cumulative. So you are not reporting week by week or day by day. It's still cumulative, so you just add them together. Again, you do the same. This is 35 divided by 100 over 2 weeks. So that is always understandable. During the third week, 10 more cases occur. So the cumulative incidence over the 3 weeks period is 45 now. It becomes 45 divided by 100. 5 more cases during the fourth week. So this becomes 50 divided by 100 again. Then 1 case there. So you have 51. Or cumulative incidence over 5 week period is 51. So it's 51 over 100. So now total over the 5 week period, the cumulative incidence is what now? 51 over 100, which is 0.51. And as I said, you can put that one if you want per 5 weeks. That is possible. So 0.51 per 5 weeks. So that is what makes it incidence rate for per 5 weeks. So it's really simple. You collect your data week by week or day by day, and then finally you report it what? For the specified study period, which is 5 weeks. So now this is what your data shows, or what your analysis shows. Now you have again, always that's what we do, you have to extrapolate it to the overall population, or the same for other conditions, which are the same conditions. So what it means that cumulative incidence over the entire 5 week period is what? 51. Now what is your generalization? Now the chance or the probability of a randomly chosen pig, now from this 100 pig, the probability that any given pig, randomly taken pig, developing the disease is what? 51%. So that's really an average risk for that 5 week period. So the likelihood or the chance of a randomly chosen pig contracting the disease in these 5 weeks is 51%. So cumulative incidence is what? It's really an average risk. It's an average risk. So I always talk about average. Now, this is almost similar to the previous data. A pig farm of 100 sows was investigated for outbreak of swine vesicular disease for 5 weeks. Now 5 sows died from other causes during the study. Now, as I said, your denominator should be what? Your population at risk you should be able to ascertain outcome, or that means you should be able to detect whether the disease occurs or not for all your population at risk. You cannot ascertain that. If you cannot do that, then you cannot include your denominator. So what happens in this case that 5 sows died from other causes during the study. There is no information whether these sows have developed the disease or not. Most probably they haven't developed, but that's why it was not recorded for them. But they were there for some time. They were there for some time. So you can't throw away that information. They were there for some time, but they were not there the entire period. Again, you cannot say they were there the entire period because they were not there. So what you do in this case is, now the numerator will not change. The numerator will not change because, again, a 51 case is okay. So the numerator will not change. What will change is what? What will change will be your denominator. You started with what? With 100 sows. At the end, 5 sows died from other causes unrelated to this one. But there is no indication that they have developed the disease. They left. And again, you don't know whether they developed the disease after they left the place. So as a result, you just, because they were there for some time, you can't throw them away. So what you do is that the population at risk at the beginning is 100. At the end is how many? 100 minus 5, which is 95. So you add them together and then divide that one by 2. So that's what we mean by average population at risk. So you divide this one by 2. And make sure that you do this operation first before dividing by 51 by that. So what happens is, again, as I said, probably these sows may have contracted the disease, the agent, but they didn't show the signs. So they may show the signs after they left this population. We really don't know that. They may remain free the whole, but what you know that they were there for some time. They were at risk for a certain period of time, but they didn't develop the disease during that period. Again, we don't have really enough information as regard to when they left. If we know that they left at this stage, then we can We can refine it in our analysis because they were not there then the half of the period. So what we do that, we assume that some of them will live in week 1, the other week 2, week 3, week 4, week 5. Then if we take the average, then we can somehow account for the time period that they were at risk. So that's what we can do. Because the information is The information is not complete in regard to how long each of these were at risk. So what we do is what we do is just the average. So that way now, this is I think it's very close to 1 divided by 97.5, I think. Mm-hmm. So it's a little bit, provided this is like greater than 52 point something. So let's say 0.3%. So it's really not very different from the previous one in terms of the magnitude, but in terms of, for the benefit of what? For the benefit of incorporating the uncertainty about what? About whether these ones are really at risk or not, then it makes sense when at least you include that information in the denominator. Yep.
Why is it divided by 2?
It's average. At the beginning you have 100, at the end you have 95. So it's the same population. Some of them left, so you divide that one by 2. Yep.
Why is the 95 is
95 is what?
Part of 100.
Yeah. Well, what happens is this is the number of population at the beginning. Your status was 100. Then at the end you only have 95. They already left. 5 already left. So what happens is if you are looking at the average population at risk during that entire period, average population at risk, because all these 100 were not at risk the whole 5-week period. Okay? 5 of them already left, so they were not there entirely during the entire period. They were not there. So you don't know when they left. It can be week 1, week 2, or week 3, week 4 or week 5. But if you just to assume that they left what? They can live in any of these one, and that distributed over entire period may be fairly. So as a result, if you divide the population at the beginning and then population at the end by 2,
Okay.
you assume that you will get what? The average time that those individuals were at risk. I mean, the average number of individuals at risk during that entire period. So if you have really refined data as regard to, for example, when one of these left the first week, the other in the second week, then you can have what? 3, 4 different data. And still you calculate average by what? 100 plus 99 plus whatever, and then divide that one by 5. So that's what average is. Again, interpretation is the same. Interpretation, everything is the same. It's just population at risk that differs from the previous one. So this is what I mean by cumulative incidence. I mean cumulative incidence rate. So in conclusion, cumulative incidence is what? An indication of average risk. All the time for all incidents, we calculate them for the first occurrence of the disease. Once the disease occurs, they are no more at risk. So that's what it means. Again, this is the key. The length of the study period has a large influence on cumulative incidence rate. So if the study period is long, then you have a cumulative incidence will be a higher or larger. This is the term that we usually use in outbreaks, attack rate, which is similar to cumulative incidence rate. This is used in outbreaks. We look at this in detail when we start outbreak investigation. In the same way, we look at only new cases and the numerator, but the denominator here in attack rate, the denominator always remains what? At-risk population, initial at-risk population. That means population at risk at the beginning. So that's what attack rate is. It will not change. You don't calculate average population for attack rate. It always remains population at risk exposed at the beginning. Yes?
So you say the new cases are what are counted in the denominator. But
New cases are the same. You count only new cases for attack rate, but the denominator remains population at risk at the beginning. It will not change. For example, like if any outbreak is related, for example, with this hurricane, because of all hospitals are closed, and because of probably the water that is lying on the ground for a long time. So if any outbreak occurs in that area, now population at risk will be what? The population that are exposed to that condition. It will not change.
I understand that. What I'm asking is, for the new cases, when we're talking about a cumulative incidence, like for the example where we had the week 1 through 5, we were adding up the cases week by week.
Yes.
How does the week 2, reflecting the week 1 as well, still count for a new case?
Yeah, what you are doing is the study is conducted we really specified your period here, 5 weeks.
Okay,
You study
so
for 5 weeks.
New cases within the 5 week
Within
bracket.
the 5 weeks, and that's
Okay.
what you are doing. But
Okay.
you really can't come there on the 5th week and then try to count it. In that case, you are looking at what? Prevalent cases or existing cases. So during that 5 week period, you really even don't count week by week. It should be day by day. Okay, you count them. So in week 1, you found 5 cases. In week 2, but so week 1 and 2, you add them together because we are talking about cumulative. So at the end of the day, your study period is what? The one that was specified at the beginning. So now the other measure is incidence density rate. Now, I think you might have seen that really when you are reporting incidence, change in population is really a problem. That is a problem. As I just talked about the cumulative incidence during that 5 week period. 5 animals died from other causes, but we don't know when they died. So we are just looking at what? We can say that it can happen that all the animals may die in the first week. So that means they are at risk only for 1 week. So although they perished or died during that first week, we are looking at them at their what? At risk for the at least half of that period. So as a result, that is really you are giving what? A false impression. Where the animals were just exposed for 1 week, now you are looking at it that they were there for 2.5 weeks. So that is, so change in population is really a key obstacle in calculating cumulative incidence. It gives some false impression, especially if there is high